Chris Lee from BYME presenting the social media. Good afternoon, everyone. So, like Mr. Chen rightfully introduced, my name is Etienne Fayette. I'm the head of Digital Innovation and Transformation for Dragage Hong Kong.
Okay, so I'm Chris Lee. I work for BYME as a Deputy Project Director, and to my left is...
I'm Fisher Manette. I'm the Technical Director of VSL Intrafor in Hong Kong. We're glad to be here this afternoon and share some of the trends and innovations in the field of construction from the experience as a main contractor, MEP contractor and specialist contractor. Chris?
So all our companies have supported the growth of in Hong Kong for decades, longer than me. So the next few minutes we'll be talking about how our ties with France and our system mother companies and how we are planning to go ahead with in the future. Right, Etienne?
Exactly, you're right, Chris. And speaking of decades serving Hong Kong's development, did you know that actually the building where we're sitting today, has been built 30 years ago by Dragage, BYME and VSL Intrafor, including the vast spaces where we are, the curved roof over a very short period of time, which demanded the introduction of some of the new technologies at the time. But we did not stop there, did we, Christian?
So 10 years later, actually, at the bottom right, you see these huge megatrusses spanning over the harbor, over 90 meters long, each megatruss over 1,800 tons. VSL was in charge at the time to put them up, that we can do this expansion project, linking phase 1 and phase 2. That's another special project. You see here these tunnels linking the new exhibition center, NTR, to Admiralty and the South Ventilation Building in Causeway Bay. So these eastern and western tunnels were delivered successfully by Dragage, Intrafor and BYME in 21. And this involved huge challenges because you're going right through the heart of the city, through the foundations, existing foundations, and it involved a lot of new engineering solutions. So innovation is not only IT and new materials, it's also new solutions. One of the solutions was, obviously, it's an extremely built-up area, no space. How to start with these tunnel bore machines. So you see this special launching shaft. So you have to go down to the ground, to the alignment, to start, to get this machine moving. And this was done with two twin circular shaped, like a peanut-shaped shaft, 40 meters deep, made of concrete wall panels. And this allowed free access. Traditionally, you have a lot of props across, and this allowed actually to install these tunnel bore machines. And these star wheels were stressed against it. Again, a very innovative solutions. So this solution come up with the constraints, project constraints. So the engineers are then forced to actually come with something out of the box. Etienne, what about the tunnel bore machine?
Well, you're right. So this launching solution was for the tunneling boring machine, because Dragage is mostly famous in Hong Kong for our tunneling skills, and this project was actually an occasion for us to introduce in Hong Kong the first time we had a variable density TBM. This is typically something that was not used before, and we needed this for the project that has to go between the reclaimed area of Admiralty and the natural coastline, the original coastline. So we introduced this solution for the first time, and then acting as the leader in the construction industry in Hong Kong.
So to continue the journey, we have two projects with MTR. We have the project 1201, which is basically an extension from Tung Chung Station to Tung Chung West, and this will involve the TBMs as usual. We also have another project in the northern part of Hong Kong, New Territories, 1601, which is in Kudong. So in Kudong, what we're doing is we have been assigned as a design and build project to build a new station in between the Shengshui and Lok Ma Chau stations on the East Rail. And it's going to be the first station built on an existing railway. So these are going to test us in our knowledge and how we're going to be innovative. And with the nature of these projects, I'm sure we're going to find out really good solutions, to be honest.
Actually, one of the stations, the Tung Chung station, involves a deep basement to be built, which is done with this D-wall construction. And this involves very heavy plant machinery, these trench cutters you see on the slide. And typically it's environmentally not so sustainable, so it has a lot of exhaust and a lot of noise. So Intrafor, for the world first time, came up with a trench cutter, which is actually get away from the diesel-powered engine and came with an electrically driven, very powerful engine, and which greatly reduces the exhaust as well as the noise. Etienne, other innovations?
No, you're right. The concern on this project is indeed sustainability and low carbon construction, but you mentioned also noise. And having an electric drive definitely reduces the noise, which we can monitor also with the IoT sensors. So typically on the site there is always some noise, but we want to know what noise is being made and where the noise comes from, so we can take the appropriate action. All the more because this specific project is right next to big public housing, which naturally doesn't want to have a lot of disturbance from the sites. Moving into the sustainability, Chris, what can you tell us about the news around the world?
I'm sure we've heard a lot about decarbonization and etc. So very quickly, basically for us, what we want to roll out and what we are rolling out, to be honest, is power banks and power amplifiers. So this reduces the need for our diesel demand on site, so we reduce the noise emissions. And these are very easy to set up. Couple of hours on site and ready to go. Our sister company in Australia has stepped up the game another notch by introducing the use of an antenna, which is also a power bank, but it's not powered by the grid. So in Australia, it's not so easy to get power from the grid when the country is so big. So basically what they have done is, in collaboration with Toyota, they have used a hydrogen cell to basically provide the power to the power bank, the antenna. So something we can certainly look at in Hong Kong. So, but this is all about power banks. Christian, I think we have something else.
Yeah, that's a bridge in Lok Ma Chau, the northern part of Hong Kong, where VSL supported the main contractor to come up with an alternative direction method. So there are 5 spans which need to be built over existing roads and the Fanling Highway. So the idea was to build it away from the roads in precast segments, assemble it, and then come with these multi-axle transporter, carry it up, and to bring it in a road closure, in one road closure between the piers, and then by strand jacking lift it up to the final level, then stress it together. So this was a huge benefit to the public, to the road users, as well as to work in a safer environment, not at height, and also it gives more program certainty. Bouygues as well as VSL, we are also very active in other parts of the world. A good example is in the UK, is HS2 project with this railway infrastructure. That's a viaduct to be built, 3.5 kilometers long, which is built of precast segments, which are put up with this huge machine, 170 meters long. And this machine was for the first time actually mobilized in Hong Kong, and has then been refurbished, has been equipped with additional electronics and sensors, which then allows to optimize or to monitor actually the operation centralized through live application. Yeah, maybe.
I really like this story a lot, how something we introduced in Hong Kong and then carried over to the UK, and the launching girder is enhanced, is augmented with these sensors and comes into this new world of data and optimization. On the tunneling part, there's something very similar, because we've been able to deploy robotics in a whole new scale and removing dangerous operations from the site. As well as scaling up the use of AI for optimization of the sequence of work, for optimization of the program. So there's a lot we can take away from this project in the UK and introduce to Hong Kong as soon as possible. Typically, those innovations are more direct to implement when there's a high level of mechanization, highly mechanized operation on the project. And this is the case today in Hong Kong. We BYME VSL INTRAFOR, we have this project going from Kowloon Bay to Chak Kulin, 2 tunnels under the sea for a highway project. That's the trunk road T2. And as you can see on the screen, not only are we using the tunnel boring machine to bore and erect the tunnel, but we're using those mini TBM to connect the cross passages between the 2 tunnels. And that's one of the most risky operations in a tunnel. Now we have those skills, those specific skills necessary to do that. And we have also mechanized equipment to place the precast road segment to really reduce the safety risk and enhance the reliability of the operations. But then once the structure is built, we don't stop there, Chris, right?
No, we don't, unfortunately. So we have to provide electricity, water, etc. So basically, in order to keep up with the fast pace of the tunnel sections and segments installations, we have to develop our own designs for the MIMP modules, which we do, and then we implement using also robotics where required. And all this is done on our proprietary software, CATIA. And then as a final check, we do 3D scans to make sure that what we have installed is correct. And if it's not, then okay, we go back, review and redo. But so this is basically trying to use a whole suite of digitalization to ensure that we are as productive as possible.
Yeah, exactly. And this is also how we manage to reduce the quantities and have a more greener construction, I hope. Now, you say better construction. For us, really, better construction starts with safer construction. And technology is mature in that area to support a safer construction project. In the first place, AI cameras are now in use on all the projects with very good levels of detection for all the times somebody's not wearing their safety equipment, or if somebody comes too close to a dangerous plant. So we've been implementing them on a couple of tunneling projects already, stationary AI, but also AI embedded on the trucks, AI embedded on the excavator, so as to assist the operator in detecting risky situations. And here, the availability of technology, especially in Hong Kong, is very helpful to enhance the safety of the operation. A few things we need to really show as well, which is not just external partners we can find, but also the safety know-how we come from our company and we bring outside. We have the sensors we can put on the helmet for the location of our people on site. And this is especially necessary for safety in confined spaces such as tunnel, to know exactly how many people we have, where they are, where the safety team is, where the first aiders are. So we're using this solution coming from France. You can see this on the booth if you want to visit us. And it has a specificity of being compliant with the European Union General Data Protection Regulation, which may seem as a hurdle, but we see this as an opportunity to collect more reliable data, because the relationship between people and technology becomes more of a trusted relationship, and we need that for the quality of data. And last but not least, as you may know, technology is not the magic ingredient. In the end, technology is here to serve a purpose and work with users. So we have developed our own VR simulation for safety based on our experience as a contractor around the world, so that anybody working on our job site can receive a VR training, be exposed to the virtual risks, and learn from that, so to make our projects safer. So we'll be happy to tell you more about all of this if you come visit us on the booth. It was a pleasure to give this presentation. Thank you very much.
Thank you very much.